Hi all, I am Rejeena K A, Assistant Professor, Department of Electronics, MES College, Marampally.
Today I am going to speak on transducer. A transducer means a device that converts one form of energy to other form. It is the first stage element of the measurement system. It detects and transforms the sensed signal into a more useful form. It also means a device that is capable of converting a physical quantity into a proportional electrical quantity such as voltage or current. The transducer may be mechanical, electrical, magnetic, optical, chemical, acoustic, thermal, nuclear, or a combination of any two or more of these. Block diagram of transducer. Transducer contains two parts that are closely related to each other, that is the sensing element and transduction element. The sensing element, called as the sensor, that is a device producing measurable response to change in physical condition. The transduction element, it converts the sensor output to suitable electrical form. This is the block diagram of transducer, that is sensing element and transduction elements, that parameters, pressure, temperature, force, etc. The sensing element give the sensor output and the sensor output given to the transduction element that will produce an electric signal. Basic requirement of a transducer. The basic requirement of a transducer are ruggedness, linearity, repeatability, high output signal quality, high reliability and stability, good dynamic response, no hysteresis, etc. Then the transducer selection factors. The basic transducer selection factors are operating principle, sensitivity, operating range, accuracy, etc. And it also determines the error, transient and frequency response, loading effects, etc. Then classification of transducers. The transducer can be classified based on method of energy conversion used, active and passive transducer. Then type of output signal produced, analog and digital transducer. Then transduction principle used, inductive, capacitive, electromagnetic, piezoelectric, transducers, etc. Then method of application means primary and secondary transducer. Then next one is transducers and inverse transducer. Active and passive transducers. On the basis of method of energy conversion used, active transducers. It also known as self-generating type transducer. These transducers do not need any external source of power for their operation. It develops their own voltage or current, and energy required for production of output signal is obtained by quantity being measured. Classification of active transducer. The active transducers can be divided as photovoltaic, thermoelectric, electromagnetic, piezoelectric, chemical, and others. Then passive transducer. This transducer need external source of power for their operation, so they are not self-generating type transducer. A DC power supply or an audio frequency generator is used as an external power source. These transducers produce the output signal in the form of variation in resistance, capacitance, inductance, or some other electrical parameter in response to the quantity to be measured. Classification of transducer, passive transducer. Variable resistance, variable reactance, optoelectronic, Hall effect type. The variable resistance can again be divided into strain gauge, thermistor, potentiometric, photoconductor. Then variable reactance can again divided into inductive and capacitive. Inductive transducer again divided into variable reactance, variable permeability, LVDT. Optoelectronic transducer can be divided into photoemissive, photoconductive. Primary and secondary transducer on the basis of method of application. Some transducers contain the mechanical as well as electrical device. The mechanical device converts the physical quantity to be measured into a mechanical signal. Such signal devices are called as the primary transducer because they deal with the physical quantity to be measured. The electrical device then converts this mechanical signal into a corresponding electrical signal. Such electrical devices are known as secondary transducer. In figure, the diaphragm acts as primary transducer. It converts pressure into displacement. The displacement is then converted into change in relative pressure. Hence, classification of transducer according to transduction principle. Capacitive transduction, electromagnetic transduction, inductive transduction, piezoelectric induction, photovoltaic transduction, photoconductive transduction. Classification of transducer. According to transduction principle, first one is capacitive transducer. In capacitive transducer, the measurement is converted to a change in the capacitance. A typical capacitor is comprised of two parallel plates of conducting material separated by an electrical insulating material called a dielectric. The plates and the dielectric may be either flattened or rolled. The purpose of the dielectric is to store electrical charges. The relationship between the capacitance and plate means C is equal to epsilon 0 epsilon R A by D. D is the distance between the plates, C is the capacitance in farad, epsilon 0 absolute permittivity of vacuum, epsilon R relative permittivity, A is the effective area of capacitor plates. The capacitance variation can be achieved by changing the gap with D between the plates, the common area of the plates A and the dielectric constant epsilon. One plate is kept fixed and the other is moved depending on the displacement. The most common type of variable capacitor used for measurement of displacement is a parallel plate capacitor with a variable gap. Variable dielectric is employed in the case of level measurement, for example, level indicator in chemical plant. Capacitive transducer, advantages and disadvantages. The major advantages are high stability, good linearity, compactness, good temperature range, etc. The disadvantages are high impedance, as a result very susceptible to noise. Electromagnetic transduction. In electromagnetic transduction, the measurand is converted to voltage induced in conductor by change in the magnetic flux in absence of excitation. The electromagnetic transducer are self-generating active transducer. The motion between a piece of magnet and an electromagnet is responsible for the change in flux. Piezoelectric induction. In piezoelectric induction, the measurand is converted into a change in electrostatic charge Q or voltage V generated by crystals when mechanically it is stressed as shown in figure. Photovoltaic transduction. In photovoltaic transduction, the measurand is converted to voltage generated when the junction between dissimilar material is illuminated as shown in figure. Photoconductive transduction. In photoconductive transduction, the measurand is converted to change in resistance of semiconductor material by the change in light incident on the material. These are the basic type of transducer. So I conclude. Thank you.